So today we're talking all about rates of change. My first question to you is, like, in general, I guess, what is a rate of change? So an easy one, there's lots of different kinds of rates of change. We're talking about change again, which we talked about yesterday, but we're also, you could just think about it as a rate. What are rates? But we're going to talk about an easy one to start, which is speed. Speed is a rate. Does that make sense when you think about that? Is it a good example of a rate? And my question is, what are the units for speed as a rate? So like there's lots. Kilometers per hour, I like it. So wait, units, kilometers per hour. Does anybody know another one? Miles per hour, yep. Sometimes that's written like that. Sometimes this is kph. Anybody have a different one? There's a really common one that's used in physics. If you've taken science and you've done the physics unit, there's a common one that you use in physics. And I would imagine that you would use it in grade 9. Definitely by grade 10 you'd be using it. Anybody? No? Huh? No, you could talk about that. That's a constant. That's a number. It's meters per second. That's another common one of speed. But you could have meters per hour or kilometers per second. What would you measure in kilometers per second? Yeah, spaceship or an orbiting planet or a moon or something like that would probably be moving at a speed like that. Or you could probably even do the speed of light in kilometers per second, although it would still be very, very large. And so you can mix and match and do all these things, kilometers per minute. Like you could do all those. These are just some of the common ones. So those are average speed. And what makes them a rate? This is important because if you can always kind of identify what a rate is and what its units are, it's really useful in all kinds of little like dabbly stuff that we do throughout mathematics. What makes it a rate?
It's kind of like a ratio. There's two things on either side.
Yeah.
One is like a measurement, one is like time-based sometimes.
Often time-based. Rates aren't always, but these ones are, you're right. So it's something per something. Right? And in these cases, it's something per time, whether it's seconds or hours or minutes or days, whatever it is. Time is often part of a rate, but not always. And it's something per something. And I like that you use the word ratio because it is a ratio between two things. We often call it a rate when the things are different units. So what are some other rates? Can you think of other rates? If you can't, we'll talk about a few others today. Can you think of another rate? Any kind of rate? Like when have you ever used the word rate?
Rating an outfit.
Rating an outfit. How would you think of that? So how many out of 10 or something like that? Yeah, that is kind of like a rate. Yeah, any others? Ben?
Cost per item.
Cost per item, yeah. Cost per item. Or what's another thing we do cost per? Per hour. So there's another one that's for rate. And I can think of another common one that you might see cost per. You may not have seen this very much, but when you do grocery shopping or other kinds of shopping, you start to see it. Have you ever gone to Bulk Barn? Yeah, very good. Per pound or kilogram or something like that, right? So cost per kilogram, cost per pound, cost per yard. What's that? Fabric? Oh, that's not even what I was thinking, but exactly, yeah, or per meter maybe in Canada. But yeah, if you're buying fabric, you would buy it per length, or like carpet or wood or something like that. Very good. A yard of soil is actually a cubic yard. So it's 1 yard by 1 yard by 1 yard. So it's a cubic yard, and it's about a bucket full of like a tractor kind of thing. And so if you buy soil for your garden or gravel for a project that you're doing around your house or something like that, you buy it in yards, which means cubic yards, and you pay per yard, that kind of thing. So there's a lot of costs per thing. So lots of other rates that you could come up with, and you could kind of fabricate whatever rate you wanted. But what we're talking about today is all about rates, and then a lot of what we're doing for the rest of this unit will incorporate rates, as well as there's sort of other parts to it, and we get back into equations of lines and graphing and that kind of thing. We'll look at some lines today for sure, but it's all about rates. So an average speed is a comparison between kilometers, so your distance that you've gone, and then hours, your time. So average speed is always distance over time. That's what your rate is in that case. So to calculate your average speed, you need to find the change in distance over the change in time, and look at how this is like slope, what we did yesterday. Vertical change over horizontal change. It's the same idea, okay? Imagine two people are traveling. One person's gone 200 kilometers and one person's gone 100 kilometers. Has the person who's gone 200 kilometers, have they gone faster? Is their rate higher? Well, okay, good. We didn't talk about speed and we didn't talk about time. So if the person who went 200 kilometers took an entire day to do it, and the person who went 100 kilometers only took an hour because they were driving in their car or something, then like we don't know, right? So this is what rates are all about, is a comparison between two values. And both those values are changes. Let's take a look at this graph. And we're gonna talk about it in a lot of different ways. So there's a couple of key ideas that you really need to get from today. I will try to point them out when we get to them, and I want you to really think about it, pay attention, and be mindful of it as you're doing your work today, that kind of stuff. So these are supposed to be numbered and they're not. So we're going to call this one A, we're going to call this one B, and we're going to call that one C. So we're looking at A, and we're supposed to find the average speed for each of these lines. So for A, what is the average speed? Now lines don't always give you points like this, and even these lines don't give you every point because B has some other points on there that like aren't dotted. But whenever there's a dot, we always kind of, it draws our eye to it. We think we're supposed to use those dots. You don't have to, but you might as well. So if I zoom in a little bit and I look at one, it's not letting me. If I look at one of these points, so for A, I'm going to pick this one. And what does this point tell me? "400 kilometers in 4 hours." I like it. So what's the average speed? What is the rate? How many? 100 kilometers an hour. Very good. So for A, let's write this out. They went 400 kilometers in 4 hours. 400 divided by 4 is 100 kilometers per hour. Yep.
Could you also do it where like you have like two of the dots on the grid, like say like the 400 and 300, and you just kind of do the difference between those, like over one up, like rise over one.
Absolutely, you read my mind. That's exactly what we're getting to. And in fact, that's a better way to do it. And we'll find out why throughout the rest of the lesson. I'll give you a little hint. This only worked, we only looked at one point. And that worked, but there's a reason why that worked. It only worked because we're starting at 0. So when we looked at this point and we said 400 kilometers has been traveled, it's because it started at 0 and went to 400. And it took 4 hours because we started at 0 and went to 4 hours. So it was a change of 4 hours. If my graph didn't start at 0, that wouldn't work. So using one point only works in certain situations. Very important to note. Okay, some start at 0 and some don't. And so how could we do it then if we didn't start at 0? And this will always work whether it starts at 0 or not, is pick any 2 points on the line. And so if we pick 2 close points, we don't have to even do division. And this is from 300 to 400 is up 100. And from 3 to 4 is plus 1 hour. 100 kilometers in 1 hour. And it's a straight line, so the rate will always be the same anywhere on that line. If I look at this point, it's 300 kilometers in 3 hours, 200 kilometers in 2 hours, 100 kilometers in 1 hour. They're all the same rate, and it would just depend on which points you chose, how your calculation would actually go. Any questions on that so far? Okay, try B. So again, we can look at this in a couple of ways, but I'm going to do it in a particular way just so we can do some extra comparisons. If you did it a bit differently but got the same answer, that's awesome. So I'm going to look at this point because it's right below our other point. And I guess this must be a car or something, right? Because what else goes 100 kilometers an hour? So car B only went 200 kilometers in the same amount of time. So because we're comparing on the same amount of time, we can tell which one's going faster and which one's going slower. We're still going to calculate the rate, but because they both took 4 hours, A went 400 kilometers, B went 200 kilometers, who's faster? A. Yeah, I think that's an easy question, right? So more distance in the same time means you're going faster. So this B went 200 kilometers in 4 hours. 200 divided by 4 is 50. So this one worked out to 50 kilometers per hour. What other ways could we look at this? Well, if I was sort of stuck in just using the points and I thought that's what you were supposed to do, I would maybe pick this point and this point. And this would be a change from 100 to 200. So that's plus 100 kilometers. In a change of 2 hours to 4 hours, so that's plus 2. And this is exactly like the slope formula. It would be 200 minus 100. We're going to talk about this more. You don't have to write all this down. You can just watch if you want. Over 4 minus 2, which is 100. A change in 100 over a change in 2, which is 50. 50 kilometers an hour, just like we got in the last one. Right? So it's a different way to do it. It's, in some situations, a safer way to do it by using 2 points. But if you were really, really careful and you looked closely, you would see that this was a point as well. So this was a change. If I'm reading this scale, and again, this is part of what we're doing, is you have to be able to look at a scale and understand what it's counting by. So if it goes 1, 2 squares to get to 100, it's counting by 50s. So this would be 150. And this would be 150 to 200 is a change of 50, and from 3 hours to 4 hours is a change of 1 hour, right? So again, you might be able to, but for the next one, I think you'd find that won't work. So I could make up my own points if they are nice points only. Don't ever estimate a point. But you can see that this is going through the point there, so you could use that. Okay, try C. So once again, if I look at the same point, comparing at the same time, in 4 hours, C has only gone 100 kilometers. Remember, this is only working because all three of these started at 0. So it's like 100 minus 0 over 4 minus 0. So that works. Okay? So 100 divided by 4 is going to give me 25 kilometers per hour. This could be a bike or something, or a car stuck in traffic. I don't know. Okay? And that's the slowest. But again, if I wanted to, I could compare 2 points. So if I compare these 2 points, that's a change of 4 hours, and a change of starting at 100 to 150 to 200 is a change of plus 100. And I would end up with 100 divided by 4 again. And the difference between this one is it doesn't have exact points because of the way the scale works in between. So some people might try to estimate and guess that it's halfway. Don't do that. Just use 2 points that are nice points and calculate it. Okay? But this one still works out to 100 over 4, which is 25 kilometers an hour. And remember what I said, a straight line will always have the same rate everywhere.
Is it okay if you just do it because you can see that it's 50 kilometers in 2 hours and you just divide them both by 2?
Yeah, if you use these two, yeah. Any 2 points you use will work. Absolutely. Any other questions? And we're going to do some more examples where you have to do that kind of stuff and continue to look at different kinds of these things. Does anybody notice anything else? Another way we describe lines and their rates, that's sort of related to which one's faster, which one's slower. So hold on. What do you think? The steepness of a line. What were you going to say? Steepness of a line. Very good. So yesterday we talked about slopes, and right now we're not calling it slope, we're calling it rate, but we could go back and forth with both those words. But like when we were comparing slopes, we were talking about which one is steeper. And you could do the same with rates, which one's steeper, and that means faster if you're talking about a speed. If you're talking about a rate of pay or a rate of cost, then you might be talking about which one's more expensive per item or something like that. So there are different ways that we compare rates. And in speed, this is why speed is such a nice example, because we have good language around it. A steeper slope means a faster speed or a faster rate, and a bigger number when you calculate it, which is, again, something we understand a lot of. Okay, so I'm going to make a note here. Works because we started at 0 for all 3 lines. Next one is calculate the rate of change for each line and include units. What does the rate of change represent? Okay, and for some reason 2 of these are labeled and not the third. So obviously the other one's going to be A. There's line A. So it's a little bit tricky when we sometimes we seem to ask the same question over and over again, because what are the units going to be for this one? Again, there's some hints that I can give you on how to figure this out. But look carefully at the graph. Look at the information that the graph is giving you. This one was what? It was kilometers per hour. So what is this one going to be? Anybody else want to? Earnings per hour. Or earnings is measured in? Yeah, so dollars, right? We would call it like dollars. So dollars per hour. So for this one, my units are going to be dollars per hour. And how would you describe that? What does the rate of change represent? And Royce kind of said it, earnings per hour. Or you might say hourly earning. You don't have to say it this way. Sometimes, or rate of pay, or hourly wage. Right? Like we have different words that we use. So if it's asking you what the rate represents, it's trying to get you to use like more plain language instead of just saying dollars per hour. Sometimes there isn't good language and you sort of have to just restate the rate. But for speed, what are the units? Kilometers per hour. What does it represent? Speed, average speed of the car. You know what I mean? So you can, with speed, you can use very good language to describe the rate. In some other rates, not so much. But that's sort of what it's asking when it says, what does the rate of change represent? Hourly wage, earnings per hour, something along those lines. And you would probably write it out in words as opposed to units, which we use symbols for. Okay, so let's do A. And again, some of these give you points and some don't. And in fact, for this one, I'm going to show it. We talked about this already, but I'm going to show it in a bit of a different way. I am going to use 2 points, so that's the only point on A. And if I follow it down and I look here, I could probably guess at what that is, but I'm not going to. Okay? Because it's a halfway point kind of thing, or I don't know if it's a half or not. So I'm going to use this point, because that is a point on A. What's that called? Does anybody remember? We talked about this in the last unit. Very nice, the origin. If the line goes through the origin, you can use that as a point, and it makes the math easy. So so we always do vertical change over horizontal change. So my vertical change went from 0 to 150. So 150 minus 0. And my horizontal change, again, what's this scale counting in? Jacob? Oh, you didn't have your hand up. Do you know what it's counting in? Well, what's the scale? So it's marked at 5 by 1, right? 1, 2, 3, 4, 5. These all have to be equal markings. So there's 5 lines. It goes to 5. What's this one going up by? 10. Very good. Because it was 5 markings. 1, 2, 3, 4, 5 to get to 50. What the scale is going up by is often going to be very important. Okay, so I'm using 0, 0, and 150. This is 2 and 150, and this is 0, 0. So 150 minus 0 over 2 minus 0, just like we were doing yesterday, which is 150 over 2, which because it goes through the origin, you could have just jumped to that. Starts at 0, so you could have done that, which works out to 75. And this one is not kilometers per hour, it's dollars per hour. That's not bad. $75 per hour is pretty good. What's different about B? Caleb? Doesn't start at 0. So I want to show you something about B. I just want you to stop and watch for a minute. What if I used this point only? That's 50, 60, 70, 80 in 2 hours. So 80 in 2 hours is 40. So somebody might think this person's earning $40 an hour.
You can't do it because of the flat chart at the beginning. So you have to subtract that from your earnings.
Yeah, that's exactly. You could still figure it out, but it would take more work. We're not there yet. So you could do it that way, but what if I did it like this? What if I use this one? This is 100 in 4, which is 25. Well, they're different. You can't have different rates. It's a straight line. This is telling me something. The fact that I checked both of those and they're different is telling me this does not start at 0. This is an important idea that we're going to explore over the next several days, actually. So these are all wrong, and the only way we can do it is by checking out the difference between the two. So this one was 2 and 80, and this one is 4 and 100. So to do this correctly, I do the vertical change, 100 minus 80. And remember, it doesn't matter which direction you subtract, but you have to be consistent. And this is 4 minus 2. 100 minus 80, 20. 4 minus 2, 2. $10 per hour. Not the best rate of pay. Any questions on any of this so far? And notice that that was smaller than both of those other two, which kind of makes sense, but we don't have to worry too much about that. But this doesn't work because it didn't start at 0. And not everything we do is going to have a graph. So you won't know if it starts at 0 necessarily. Okay? Okay, try C. C starts at 0, but try using 2 points. Yeah. Sure, yeah, what'd you get?
I got $20 an hour.
$20 an hour. I got the same thing. Did you do it the same way as me, or did you use different points?
No, I just saw that he makes $40 in 2 hours, so 20.
Okay, so you're kind of doing some of the math in your head. Is that right? Because that's what, oh, wait a minute. Oh, you used 1 point like this from 0?
No, the second point to the third. Yeah, that point to the.
Gotcha. To this one? Okay, so yeah, definitely doing it different. And you, like right now, you can certainly do some of this in your head, but make sure you understand that this is how we show this is how you would show this work. Okay? If you're required to, if it's that kind of a thing. I want to show you one more thing that wouldn't work. Okay, if I get these back, and then I'll show you something else that does work. I don't think you want to write this down because it'll muck up your note, but just watch. If I did 40 minus 80 over 4 minus 2, what did I do wrong? I crisscrossed the numbers like we talked about yesterday. 40 minus 80 is negative 40. 4 minus 2 is 2. Negative $20 per hour. Why do I know this is wrong? Because of how the line is sloping. We know positive slopes go up to the right. Is that going to be true for positive rates as well? Absolutely. A positive rate and a positive slope are the same thing. Can a slope be negative? Can a rate be negative? If the line was going down, can that happen in real world?
You couldn't do it for speed, but you could technically do it for money.
Yeah, and you know what? I would even challenge you could do it for speed. It depends on your point of reference. What if you're talking about your speed like towards your home or something like that? Or what if you're talking about your speed away from home, but you're actually going towards your home? That would be a negative speed. So it depends on how you talk about it. If you're talking about your earnings per hour, you're earning money. What if you're losing money for some reason? That could be a negative rate. So it sort of depends, and we won't see really negative speeds in this course, but actually, I shouldn't say that. We might kind of talk about that. But depending on what direction you're going, you would talk about it being a positive or a negative slope or a positive or a negative rate. So I know this is wrong because it's negative and I can see that the line is going up and increasing. Another way that I could have done this that would have worked though, 40 minus 80 over 2 minus 4. So I have not crisscrossed, and I'm going to end up with two negatives, which will cancel and still give me positive 20. So again, order won't matter as long as you're consistent. Everybody good? Look, there's an example right there. It's distance over time, kilometers per hour. So it's speed, but you're starting away from your destination and going towards it. So your distance is decreasing. This is really, in real life, a matter of perspective. How are you, like, what are you talking about? Your point of where you start and the point of where you end. So if I pick 2 points, again, these look like they're counting by 1, 2, 3, 4, 5, so they're going up by tens. So that's 110, 120 in 1 hour. You don't have to use the same ones as me. This looks like 4 hours, and it looks like 30. So again, you have to do vertical change. I'll start with my second point. In my mind, it's further to the right. You might think this is the first point because it's lowest. Like, I don't know. It doesn't matter which one you call first and call second as long as you're consistent. But I'll start with this one as my second point, which means I start with the 30 minus the vertical value of this one, which is 120. And then go back to this one, which is 4 minus 1. 30 minus 120. Very good, negative 90. And that negative is going to be super important, isn't it? Because it's going to describe our line in a really important way. 4 minus 1 is positive 3. So what does this work out to? Negative 30. And what are our units? Again, yeah, I can just look at the units that go up and down over the units that go left, right. Like that'll always give you the units of the rate, if you haven't already noticed that. Kilometers per hour. So negative 30 kilometers per hour because you're going towards your home or whatever 0 is instead of away from it. Not something you might have thought about, but again, that's something they talk a lot about in physics in later years, not in grade 9 probably. Again, we have 3. I don't know that we're going to do all 3 again. I guess we can quickly. I'm going to give you a couple minutes to do all 3. And we're supposed to, and be mindful of what the units are. And we're supposed to be saying what they represent as well. Oh, the difference in this one is there's no points highlighted, so you have to find your own, right?
Where it is on the y-axis and the x-axis, or do you have to find 2 points and then do the math?
So all 3 of these start at the origin. So why don't you try doing it both ways? But you're right, because they start at 0, you could do the sort of cheating way and just use 1 point. So I started for A, I used 2 points. But I used 2 points that are close together, so that'll make it easy. So I'll show you how I did it. I did the sort of 3 different ways. Some of you are done all of them. Some of you are only partway through. So you can finish off the other 2 either now or after. But the first one, like I said, I picked 2 points that were not the origin, were not 0, 0. And this is the way that will always work. But if you really know the difference between lines that start at 0 and lines that don't, then you can cheat, or you could just recognize that using 0, 0 is useful. And so I kind of did some extra math that I didn't have to here, but 90 minus 0 is just 90. 3 minus 0 is just 3, so it ends up being 90 over 3. Like, that's why just cheating and using 1 point when it goes through 0, 0 works. And so then here I showed without this step, just using 1 point because it goes through 0. This was 30 apples in 6 boxes is 5 apples per box. Right? And so I don't know if you noticed, but this was a bit of a weird unit, apples per box. Why would you have different numbers of apples per box? Why would that be a thing?
Depending on the size of the apple.
Size of the apple? So bigger apple, smaller apple, same box size? Could be. Anybody else? Dylan? Yeah, what would they do? Or different companies, you mean?
Yeah.
Different companies choose different box sizes? Yep. What else? Would your parents tend to buy a box that has 50 apples in it? Why?
A lot.
Yeah, what were you going to say, Jay?
Don't go bad.
Yeah, exactly. Who would buy a box with 50 apples in it?
A restaurant, maybe.
Restaurant? That makes apple pie? Grocery store? Something like that? Or right? So, I mean, companies offer different box sizes for different applications. So this might be like an orchard that caters to restaurants, big, small, farmers market, people maybe, and then just an individual family who might only need 5 or 10 apples. And maybe you can buy them single as well, right? But that makes sense. And believe it or not, I know these math class examples come across as kind of boring, but this is real life stuff that people deal with. Like, somebody in the world works for a company and has to decide the size of boxes and how many apples are going in them, and then what they're going to charge per box. Like, people decide those things, and how successful a company is depends on those decisions. And that's all related to math, right? Okay, we got one more here. After work, this one's an interesting one. After working for 5 hours, Bill made $110. And after working for 20 hours, Bill had made $335. Calculate the rate of change in this situation. What does the rate of change represent? And we're going to explore this. So there's a right way and a wrong way to do this question. Right now we're just exploring, and this is what your homework actually looks like, questions like this. But once we get make sure you understand the right way of doing it. And we've already talked a lot about why the other way is wrong. Ben, you already started this question. What did you try?
Well, I did I added them both up. Well, I'll start that over again.
That's fine.
I divided 110 by 5, and it's $21 per hour.
Okay, stop right there. 110 by 5. Makes a lot of sense, doesn't it? Because if he made $110 in 5 hours, and sorry, you said that was 21?
Yeah.
$21. 22? I think it might be 22, but in the end, it doesn't matter too much. But 22, and we're saying $22 per hour, but I'm putting a question mark beside this. Because then what did you do next, Ben?
I divided 335 by 20.
Okay, and somebody else, tell me what that is if you have a calculator out. 16.75. What do we notice? Not the same. So we've already talked about why this would happen, but this is telling us something important. Does it mean he earned a different amount on the first day from the second day? I mean, it could. Maybe he's got 2 jobs and they pay different rates. That's not what's happening here. What is this telling us? Caleb?
Flat rate.
That there's a flat rate. It doesn't start at 0, just like we talked about. So you can't just use a single point. This is like a single point. I've got 2 single points. In 5 hours, it was, 110. And in 20 hours, it was 335. So there's some other amount that's factoring into this that's causing this to happen. So if you don't know, so we didn't know if it started at 0 or not. Because maybe Bill is a plumber and plumbers get paid an amount just to show up at your door. And we don't know that. So in all of these questions, if you don't know, you could try both on your calculator, and if they are the same, then it goes through 0. That's like a check. But really today what you're supposed to do is use both points, and we do 335 minus 110 over 20 minus 5. 335 minus 110, Zainab? 225. And 20 minus 5 is 15. And 225 divided by 15 is $15 per hour. That is the correct way to do these where you won't make a mistake because we don't know if it starts at 0 or not. This is what your practice tonight is like. It's a few of these questions in words. So you have to be able to read through the words and understand them. And you have to recognize that you can't just divide 1 point. That's cheating. It might work for some. It might not for others. And in fact, if I did this and then checked one of these and it was the same, then it goes to 0. Like it would have to. You know what I mean? So that's another thing that you can do to sort of check some of this stuff.